Good afternoon, everyone. I'm Steve,
And I'm Scott.
and together we're Backyard Musings. I'm in Apple Valley.
And I'm still in Utah, and we're still talking science and technology.
So this is an interesting one because I was in the construction industry, and so it's about concrete. So very interesting, and I'm going to pick it apart too. I happen to think I'm an expert at concrete. Researchers at USC have developed a powerful AI model, Allegro-FM, that's its name, capable of simulating over 4 billion atoms at once. This breakthrough enables the design of next generation concrete that captures carbon dioxide and could last for centuries, possibly even rivaling the durability of ancient Roman structures. Effects of the current ice age are rapidly intensifying. Droughts, melting glaciers, and increasingly destructive storms and wildfires are becoming more frequent and severe. A key factor driving global warming is the steady release of carbon dioxide into the atmosphere. We've talked about this. This research was published recently in the Journal of Physical Chemistry Letters on June 20th, 2025, and was featured as the journal's cover image. Would you like to know more?
After witnessing the devastating January wildfires in Los Angeles, USC uh, Vertibi
Yep.
Professor Vertibi, okay, Professor Achiro Nakano, who specializes in computer science, physics, astronomy, and computational biology,
That's a
began,
wide range.
yeah, began rethinking how science could help. He contacted a longtime researcher and collaborator, Ken Ichi Nomura, a fellow USC Vertibi professor with expertise in chemical engineering and material science. The two have worked together for over 2 decades. So,
Their conversation led to the creation of Allegro-FM, an advanced AI-powered simulation platform. In their theoretical research, the model reveals something remarkable. It may be possible to reabsorb the carbon dioxide released during concrete production by embedding it back into the same material. Quote, you can just put the CO2 inside the concrete and then that makes a carbon neutral concrete. End quote, Nakano said.
huh, interesting. Nakano and Nakamura, or Nakamura, Nakano and Nomura, along with Priya Vashita, a USC, am I pronouncing this right? Vertibi
Yeah, vertibi, whatever. Yeah.
professor of chemical engineering and material science, said Rajiv Kalia, man, a USC professor of physics and astronomy, have been doing research on what they call CO2 sequestration,
Sequestration.
or the process of recapturing carbon dioxide and storing it, a challenging process.
By simulating billions of atoms simultaneously, Allegro FM can test different concrete chemistries virtually before expensive real world experiments. This could accelerate the development of concrete that acts as a carbon sink rather than just a carbon source. Concrete production currently accounts for about 8% of global CO2 emissions.
The breakthrough lies in the model's scalability. While existing molecular simulation methods are limited to systems with thousands or millions of atoms, Allegro FM demonstrated 97.5% efficiency when simulating over 4 billion atoms on the Aurora supercomputer at Argonne National Laboratory.
This represents computational capabilities roughly 1,000 times larger than conventional approaches. The model also covers 89 chemical elements and can predict molecular behavior for applications ranging from cement chemistry to carbon storage.
Quote, concrete is also a very complex material. It consists of many elements and different phases and interfaces. So, traditionally, we didn't have a way to simulate phenomena involving concrete uh, material. But now we can just use this Allegro FM to simulate mechanical properties and structural properties, Nomura said. I
Yeah,
don't know about that.
so the
Heck,
components of concrete is water, gravel, sand, like a fine sand type, and what we call
cement. Cement.
and the cement. And the cement is chemical in nature that reacts with the water to create a paste that grabs onto to that gravel,
Yeah,
right?
a lot of lime in. There's a lot of lime in cement.
Yeah, and you could put different admixtures to make the concrete perform differently. Like on a hot day, if you want it to make it plastic so it'll go quicker, you do an additive. And in the wintertime, if you want it to move slower, you put in a different additive. Concrete is a fire-resistant material, making an ideal building choice in the wake of the January wildfires. Can you imagine concrete houses? But concrete production is also a huge emitter of carbon dioxide, a particularly concerning environmental problem in a city like Los Angeles. In their simulations, Allegro-FM has been shown to be carbon neutral, making it a better choice than other concrete.
You know, you say concrete houses. I know cinder block homes are cooler in the summer and warmer in the winter.
Same type of theory. Yep.
Yeah. Okay, so where am I at here?
Breakthrough.
Oh yeah, the breakthrough doesn't only solve one problem. Modern concrete only lasts about 100 years on average. Really, that's interesting. Whereas ancient Roman concrete has lasted for over 2,000 years.
True story.
But the recapture of CO2 can help this as well. Quote, if you put in the CO2, the so-called carbonate layer it becomes more robust, says Nakano.
In other words, Allegro-FM can simulate a carbon-neutral concrete that could also last much longer than the 100 years concrete typically lasts nowadays. Now, it's just a matter of building it. The professors led the development of Allegro-FM with an appreciation for how AI has been an accelerator of their complex work. Normally, to simulate the behavior of atoms, the professors would need a precise series of mathematical formulas, or, as Nomura called them, profound deep quantum mechanics phenomena.
But the last 2 years have changed the way the two research. Quote, now because this machine learning AI breakthrough, instead of deriving all these quantum mechanics from scratch, researchers now are taking the approach of generating a training set and then letting the machine learning model run. Okay, that's according to Nomura. This makes the professor's process much faster as well as more efficient in its technology use.
Allegro-FM can accurately predict interaction functions between atoms. In other words, how atoms react and interact with each other. Normally, these interaction functions will require lots of individual simulations.
But this new model changes that. Originally, there were different equations for individual elements within the periodic table with several unique functions for these elements. This is my buddy. With the help of AI and machine learning, though, we can now potentially simulate these interaction functions with nearly the entire periodic table at the same time, without the requirement for separate formulas.
The quote, the traditional approach is to simulate a certain set of materials so you can simulate, let's say, silica glass, but you cannot simulate that with, let's say, a drug molecule, Nomura said.
Huh. The new system is also a lot more efficient on the technology side, with AI models making lots of precise calculations that used to be done by a large supercomputer, simplifying tasks and freeing up that supercomputer's resources for more advanced research.
Quote, the AI can achieve quantum mechanical accuracy with much, much smaller computing resources, Nakano said. Nomura and Nakano say their work is far from over. Quote, we will certainly continue this concrete study research, making more complex geometries and surfaces, Nomura said. And just to add that, what's thought up in the lab by the brainiacs is different than what goes on in the field. Concrete is mixed at a ready-mix plant, and all those materials come together and get dumped into a ready-mix truck, and that truck starts spinning. Well, that truck's going to have leftover stuff from the last. They try to clean it as well as they can, but it doesn't always get, purely clean.
Well, and they're doing these studies or these tests in a controlled environment. You're not controlled in the outdoors. You don't know whether it's going to be cold or whether it's going to be hot or if it's going to rain. You don't know. So, but yeah, I mean,
this is interesting.
Yeah.
Let's test it out at the ready mix plant and see if it works.
Yeah.
All right, folks.
All right.
Thanks for joining us. We'll talk
Take
to you
care,
in the
everyone. We'll
morning.
see you on the next one. All right.